Hi everyone, welcome to the second last session of the day. It's great to be here at DevConf. Having a good day everyone? I'm having a good day, it's been a great week, really enjoying it. I'm quite tired now and I have to talk to all of you. And let me introduce myself. I'm Donald, that's me. I'm a software engineer, technical lead, consultant, general pain in the ass at Equal Experts. Been working with the company now for about 6 years. And I've been working, the company's big, it's about 4,000 people. We work with many customers. But I've worked mainly with people, UK retailers. So I've learned a whole lot more about retail than I ever hoped to. I've been working, earning a living writing software since the mid-90s, so I guess that makes me quite experienced. I'm lucky enough to have screwed up continuous delivery in many ways, so I feel really qualified to talk about this subject. So who's afraid of continuous delivery? When I first proposed this talk to DevConf, I imagined I'd work through a list of things that stop us from doing continuous delivery and work through them one by one. But my subconscious was a little bit ahead of me when it gave me this title, which is Who's Afraid of Continuous Delivery? And the more I thought about it, the more I thought, it's fear. It's fear that stops me. It's always fear. It's sometimes my fear, sometimes other people's fear, maybe your fear, that stopped me along the way from doing continuous delivery. And then I thought about who's afraid of continuous delivery, literally. So we'll talk through some of those things. We'll have a look at who they are, and we'll talk about some of their fears. So start with a definition of continuous delivery, which I don't think is particularly controversial, but just to kind of get it out of the way and see what we're talking about. And then talk about some of the benefits, and then talk about who's afraid, and maybe we can talk about how to address some of those fears in a positive way. This isn't a talk about how to do continuous delivery. That's probably the next talk in this room. That would be Craig's talk later. So if you were looking for that, that would be more the next session. But this is more about what's stopping us from doing it. We understand the concept, but why do we still refuse to do it? And maybe do we even want to do it? So I'm asking you that now. Do you want to do this? At the end of the session, I'll ask you the same question. Do we even want to do this? So what is continuous delivery? A couple of years ago, one of my colleagues, Phil Parker, did a talk at DevConf, and he listed the things, some ideas to get to continuous delivery, and he defined it as how fast the customer wants to go. I'd like to use a slightly different definition, and referring back to the keynote address, we talked about cycle time. So cycle time is about how long it takes us from when we start writing the code, from like the first line of code we write, until that feature is in production. And so cycle time might be, if there are many features that we're developing, might be 6 weeks or a few months, sometimes a year. And I'm saying my definition of continuous delivery is the more you can bring the cycle time down, the more continuous things are. And to be particularly aggressive for the purpose of this talk, I'd like to think about multiple times per day. So we're saying maybe there's a pair of programmers working on a feature, they work on it in the morning, and they release it in the afternoon. And maybe there's another pair in the team doing the same thing. That's how you get to multiple releases in a day. Is anybody scared yet? I am. I'm still afraid of this. So if you're afraid, this is a good place to be. Is anybody doing this? Is anybody doing multiple releases? Excellent. If you're not doing multiple releases per day, maybe multiple releases per week? Lots of us, that's excellent. Do you release on Fridays? If you don't release on Fridays, what are you afraid of? This is scary. So why do we want to do this crazy thing? Why would we want to release multiple times per day? So the first thing is the value of it. We're saying, imagine you work on some code in the morning and customers are using it in the afternoon. So they're deriving value from it. They're getting this new feature that they didn't have before. They're excited. Maybe they want to pay for it, so we're starting to get revenue for this feature. But we start to get feedback. That's really important as well. So they tell us what they like and don't like, or we observe the way that they click around, we observe their behavior, and we can see whether they're using the feature, whether they like the feature, maybe whether there's something wrong with the feature. We can conceive of improvements to the feature. We start getting feedback really soon so that tomorrow we can improve it. We'll come back to this third point quite a lot. It's about the risk. So I won't harp on it now. We'll come back to it several times. And I've experienced this. I've experienced the bliss of this. About 6 years ago when I joined the company, I joined a team that was releasing multiple times per week rather than per day. And the team had a product manager who really knew what she was doing. She had a clear vision. She was able to break things down into these incremental steps. We had a business analyst who was able to provide excellent acceptance criteria for these features. And we had a team who really wanted to work this way, including a QA engineer who wanted to work up front on the testing. So we didn't have testing right at the end. And we were able to make multiple releases per day or per week. We were able to see our customers using the features very quickly, and we got excited. We really learned to love this. We made mistakes. We released broken things every now and then, but we were able to recover really fast. So it was an exciting time, and it only lasted for a few months because new people came into the team. They didn't want to work this way. The BA left and went somewhere else. And eventually this broke down, and we weren't able to do this anymore. And ever since then, I've been trying to do it again and haven't quite got there. So who's afraid? We'll talk about 4 groups of people. So people in IT governance, people who manage what happens in IT is the first group of people. Then we'll talk about 2 groups of engineers. And somebody told me that when I do a talk like this, I have to have 4 points. So I arbitrarily broke the 2 groups of engineers into 2 so that I'd have 4 points. So developers and quality assurance engineers, I think most of us think that we might be comfortable in either role. The things are changing. The distinction between the two has broken down a bit. And then finally, product managers. What are product managers afraid of? So let's start with the governance people. The idea is that change causes failures. I looked for definitive stats on this, and I wasn't able to find much, but the most kind of definitive thing I found was the Google Software Reliability Engineering book, Site Reliability Engineering book. And they talked about the majority of software failures happening in the wake of configuration changes or software changes. So I guess that's somewhere more than 50%. Quite a lot of failures are caused by changes. And so what do we try to do? We control the changes. We say, let's not make changes. And one of the groups of people that does this is called a Change Advisory Board. They're not a change approval board, even though they work with software tools that have buttons on them called approve and reject. But they don't like to be called that. So they're helping us, they advise us on how to make changes. And a few years ago, we worked with one of these groups, and there was somebody who came to us and told us, we're releasing too frequently. Could we please slow down because we're introducing too much risk into the system? And so we had to work with her. We had to say, we understand your concern. Remember I said I was going to talk about risk. So we're going to make the same amount of change anyway. Are we going to do it in small changes with a little bit at a time, or are we going to batch up those changes a month or 6 weeks or 2 months at a time and make these massive changes? And she started to come around to the way of thinking we had to earn her trust by making small changes and making sure we didn't break things, and also by fixing things quickly if we did break things. But after some time, we managed to earn her trust, and she became one of our advocates. And she worked with us with the Change Advisory Board to help us to oil the wheels of the bureaucracy and make the changes quicker. It was hard. We had to think about her fears and address them and earn her trust. I've recently been working on a cyber attack, on a response to that in the last few weeks. And it's been really hard, and if I didn't fear it before, I definitely fear it now. It's not something I'd like to do again. So the people who are responsible for preventing cyber attacks are often information security or InfoSec, and they're often really helpful groups of people. They have this kind of advisory or kind of expert role in an organization. They help us as developers to build security in and not to hack it on at the end. But sometimes they fall back on this old technique called a penetration test. So a couple of years ago, we were addressing our fear of a hack with a penetration test. And so a consultant came along, worked with us, we gave him about a 15-minute description of our system, and then he went away and he came up with a quote that took a few weeks. In the meantime, we had features we would have loved to release, but we had to wait for the penetration test to happen. Took a quote, got the quote approved. That took some time, spent the money on the quote. Eventually, the consultant came back and he sat with us for about half an hour, and then spent 2 days going and attacking the system with a fairly standard set of tools. And after that, he came back to us, and this happens every time. There's kind of a set. You have to be valuable. You have to earn that fee that you've charged. So he came back with a set of fairly kind of standard things, like the version of TLS. We were supporting an outdated version of TLS. We should stop doing that, switch it off, because that was a vulnerability. Or the way we'd configured the cloud services wasn't best practices, so we'd left some vulnerabilities there, and we should go and do those things. But after he'd spoken to us, he said one more thing. He said, I really shouldn't be telling you this, but you don't need to do any more penetration tests because you don't have any data that's worth stealing. And we said, yes, we agree. Thank you so much. And we thanked him for his time, and we went to start thinking about the vulnerabilities that he'd found, but we also went and booked the next penetration test. And when I did that, I had to take a long, hard look at myself in the mirror and say, why did I do that? I was also afraid. But I was afraid of a different thing. So I was afraid, imagine somebody went and made the effort to steal the data that isn't worth stealing, and then somebody else found out about that. They would come to ask me and say, did you do a penetration test? And I would say, sheepishly, no, I didn't. And then somebody would shout at me, and then I would be sad. So we went to all the effort of doing another penetration test just to avoid feeling sad in that way. And so what I realized was the other fear is I was afraid to learn how to be better at security because that's what it really takes to make your application secure. You can't entrust that to an outside consultancy. You have to take responsibility for that yourself. And so that's what we had to do, was to get better at it. Okay, we didn't have to get so good at it because the data wasn't worth stealing. But we still had to be clear to ourselves and learn in subsequent projects how to do this ourselves rather than to hope that this kind of wishful thinking that somebody else is going to come along and protect us. Architects, the next group of governance people. So what do architects hate? Architects hate duplication. Don't repeat yourself. And so one of the things they introduce often into a project is dependencies on other projects. So this is not a software dependency. This is a dependency where you say, in order to release my product, somebody else has to do some work on theirs. This is probably the subject of another whole talk. And I know this because I did it 2 years ago at DevConf. It was about microservice reuse. And the story there was about how the dependencies on my project delayed our release by more than a year. So it's really worth avoiding that kind of dependency, or at least thinking really carefully before you accept it in your architecture and your plan. And so that's what I learned, and I thought, next time I have to do this, next time an architect comes and tells me not to repeat myself, I'll think carefully about what that means. Does that mean I go and fork the other repo and make the changes, or do I submit pull requests to that repo, or do I just make a whole new thing that does exactly what I want it to do and doesn't do the other things that that thing does? I'm not sure yet, but I know I'll think a little bit more carefully next time. So we had a quick look at governance. We only have time for a quick look at each of these groups, but let's look at ourselves, look at developers. This is probably the hardest slide I've got, and I'm not sure that I'm going to do justice to it. This is, my code isn't ready to go. I'm afraid of having to have my code ready to go all the time. My code needs to be always deployable. And I'm proud to say I didn't think of this slide until quite late in my preparation because I kind of do this by habit now, but I had to learn it the hard way. So what does it mean? I think it means something like this. It means that when you run your pipeline and it's green, you know that it works. That's all you have to do. You don't have any other manual things to do to make sure that your system works. And if you don't know how to do that, Craig will talk about it in the next session. So I'm off the hook. The other thing is, if your pipeline is not green, if your pipeline is red, that's an emergency for your team, and your team should stop. I'm talking to myself here. My team must stop doing what it's doing and go and fix that pipeline. And the third thing is, we're allowed to have incomplete features, but they have to be hidden behind feature flags. So we can test them in prod for those of us who know how to do it, but we don't want our paying customers to be exposed to these incomplete features. So that's how you're kind of able to work incrementally towards a feature, but make sure that your system still works. And that's all I'm going to say about this for now. But I remember when I first heard about continuous delivery, this is what I was afraid of. Imagine you come in on a Monday morning and it's release day and you're excited. And so you fill in that form on one of those systems to get approval. And then you go and you ask people to approve the release, and then they won't. And then you need to convince them because they're busy with something else, and you offer them beer. And then they go and they approve it. And in the meantime, your colleagues are running some last-minute automated tests. And some of them fail and they fix them quickly. And now it's lunchtime. And now you've got your approval and your tests are all passing. Quickly grab a bite to eat. Come back, start your very time-consuming release process, which is well documented, but there are a whole lot of manual steps. Finally, you get to the point where you can release. Then you do your manual tests in production, and you find there's a minor problem, so you go and do it all again. Finally, you have a beer at the end of the day, and you celebrate. And then somebody says, we're doing this again tomorrow because we do continuous delivery. That's very frightening. You must feel like Sisyphus. You're pushing the rock up the hill during the day. You go and rest at night, it rolls back down the hill, and you do the same thing again the next day. Clearly, this won't work. We have to do better than this. So we have to automate the testing. We have to automate the release process. And probably a little bit more subtly, we have to automate the approval process as much as we can, and that might involve buying a lot of beer. So when we think like this, we might get to a point where we say, we have automation, but we don't have enough of it. So we have a manual check at the end. We have one last test that we have to do. So we can't possibly release until we've automated that. So this is a kind of perfectionism, and that's what this slide is about. So perfectionism to say, we've got some automation, but it's not quite as good as we'd like it to be. So we don't have enough automation of our testing or these things that I spoke about now. And there's a general idea of perfectionism. So perfectionism stops us from having what's good enough. And some other ideas are, we can think of some really obscure edge cases. We could deal with them with maybe some kind of generic error handling, but we decide no. What about if there are other edge cases we haven't thought about? We may not release until we've thought them all through. Or heaven help us, I know just about everybody in the room is doing test-driven development, so this isn't really an issue for you. But for the 2 people in the room who aren't doing that, you may be concerned about test coverage. So you may be saying, well, you need to have 80% test coverage, otherwise we can't release. But that just kind of drives us to build these meaningless tests that just push the coverage up and don't test anything. Or maybe we say, this thing works and we can release it, but our cloud costs are too high. It's not efficient. We need to bring the efficiency, we need to improve the efficiency. Or our things are automated, but they're just not fast enough. So we can't release until we've got a faster deployment pipeline, or our tests are fast, or whatever the reason. And I think the approach to this could be something like, all of these things are valid, but we're going to release anyway, and we're going to say, put these things on the backlog as requirements that we haven't addressed yet, and they can fight it out with other requirements. So we'll prioritize them. Let's not let them delay the release. Let's not let this kind of perfectionism delay us. We want to move forward to the release. But we can go and work incrementally to address these things one at a time when we get to them. So I know all of you are doing pair programming. Everybody in the room is doing pair, except for that one person who's not doing pair programming, and then you rely on this thing. So the fear here is we say, we don't want one set of eyes to have seen the code before it goes into prod. We know that that's dangerous, and we're justifiably afraid of that, so we say, let's not do that. We know that the moment we show our code to one other person, they're going to spot some error that we didn't spot. So we have to have some kind of code review. Pair programming is continuous code review, but maybe we resort to something like a pull request. And the way that works is, remember, we want to code in the morning, release in the afternoon. So we write our code in the morning, tests are all passing, pipelines are green, Everything looks cool. We've refactored it nicely. We're happy with the design. Go for lunch. And in the meantime, we submit the pull request. Then we go for lunch. We come back after lunch. Nobody's looked at the pull request. And we start nagging people. We say, please, can you look at my pull request? I'm busy, I'm building my own feature. Okay, I'll buy you beer. All right, I'll look at your pull request. So they look at the pull request. Eventually, they find a small problem. You say, yes, definitely a problem. You go and fix it. In the meantime, you've blown a hole in your continuous delivery. So you wanted to measure it in hours. You wanted to be saying, my continuous delivery is measured in a few hours, and now you've added 1 or 2 or 3 hours to the process. So I'm not saying pull requests are a bad thing. I'm just saying we need to be careful in our teams to make sure that they don't slow us down to the point where it's a massive impact on our ability to release. We have to find ways to work together to make it quicker. And maybe that involves interrupting somebody's flow so that they can review our code and then pay the compliment back later, interrupt my own flow, I'll review your code, something like that. So we talked about developers, and now we're going to look at that next group of engineers, so quality assurance. And who's not afraid of this one? The code isn't fully tested. We live with this all the time, don't we? We think, how do we know the code's tested? We don't want to release untested code into prod, even those of us who do TDD. So we say, how do we solve that problem? We say, well, we're going to make somebody responsible at the end to test it and sign in blood that the thing works. And the rest of us are off the hook. We don't have to do the work anymore. Now, you think pull requests introduce delays. This is insane. Now you're putting all this work on one person, and this person becomes a bottleneck. They have to go and do the testing on their own, and they're busy testing 5 other features before they get to yours, and now you're looking at days, if not weeks, before you can release. So the solution to this problem, as you all know, is to not do that and to have that person involved in your team in another way. So to be teaching everybody how to do quality assurance so that it's done together and so that each developer can take responsibility for the quality of their own code and for the quality of their own feature before they release. So that's a different way of looking at how things are tested and making sure that they are. We each have to take responsibility for it. And then, of course, we need to get to end-to-end testing, fairly obviously. So we did this a few years ago. We were really good at TDD. We had excellent unit tests. Our pipelines were all green. We then produced this thing we called a feature test. A feature test was where we'd isolate our service. So we would mock out our dependencies with something like WireMock. We would isolate it on our laptop or in a pipeline. We'd write tests that kind of stimulate the thing from its APIs, from its interfaces, and then we would make sure there wasn't any concurrency, because then that complicates the way the tests are written, because we have to handle messages in different orders. So we tried to isolate it as much as possible, and then you hammer the thing. Then you break make WireMock break the responses from the dependency. You give a whole lot of bad input. You all kinds of tests. And then you start to believe that the thing works. And you say, this is cool. Now, we're happy that it works. But obviously now we have to integrate with our dependencies, remove the WireMocks, and put the dependencies in place. So we did that. So what happens then is something fairly obvious. The tests run really slowly. So your feature tests run in a minute, and these integrated tests run in like 10 or 15 minutes. And so that already starts to impact on your ability to deliver. But that's the least of your problems. Because then one of the dependency teams is working on their system, on their service that we're dependent on, and they go and take it down because they're busy changing it in some way, and then tests just arbitrarily break. And we don't know. Nobody's communicated this to us. We just see our pipeline goes red, and we don't understand why. Or even worse, we're dependent on data in their system. So the test data problem, where we say, we need that data to be in that system. This team decides to do a restore from prod. The test data is gone forever. Our pipeline's permanently red. And so we eventually gave up on these tests. We said they take too long to run, and they cost too much to maintain. So we gave up on them, and we deleted them, which is possibly a bit irresponsible, but at least we were able to make progress. And I'll talk about something fairly controversial here and say, contract testing and that would be a subject for another talk. Maybe I'll propose it for DevConf next year. But the statement I'll make, and please come and fight with me afterwards, is that if you have that kind of feature testing where your service is isolated and you have contract testing, you don't need to do this. So at the end of it, it's probably a bit unfair to blame the QA person, but it's often the QA person who comes up with this. They say something like, our service responds in 400 milliseconds, but the industry standard is 200 milliseconds, whatever that means. So the industry standard for this kind of service is 200 milliseconds, and so we can't release because that's just not good enough. So you make up non-functional requirements at the end. We need 5 nines reliability, and we don't have 0 downtime deployment, so we're never going to get 5 nines. That's not good enough. And I guess this would be a subject for another whole talk, and I know because I did it last year at DevConf, I talked about non-functional requirements, obviously, and the idea was in that, how do we be very deliberate? How can we be deliberate about these requirements and think about the requirements that actually apply to our system rather than ones that we make up at the end? And again, kind of obviously, when we come up with them, we put them onto the backlog and we say, we live with the behavior that we have now. Now we have a requirement that we didn't know about before. We're going to do it later. That requirement's going to fight it out with our other requirements so that we can make progress and we can make our release. If we don't do that, again, we can interrupt our continuous delivery a lot. So that was my take on the view of quality assurance. And we're coming to the end of our groups of people. Let's talk about product managers who also have a lot of skin in this game. So about 15 years ago, I was a product owner in a Scrum team, and we were releasing maybe every 3 weeks. And the thing that I remember, the emotion that I feel when I remember that time is pressure, just this relentless pressure to deliver for the team, to say, if I don't have the requirements ready for them by the time the next sprint starts, they're going to be idle. This talented team is going to be stuck, and they won't have anything to work on. I'm going to be wasting the company's money. They're going to be angry and frustrated with me. Enormous pressure. But that was when I had to be ready every 3 weeks. Now what we're talking about is something has to be ready every day. And not only does it have to be ready, but it has to be broken down into small increments. It's a very frightening thing, and product managers can be afraid. So the way I think we can approach this is to say, that's too much work for one person. We can't expect all that pressure to be put onto the one person in our team. We all have to take responsibility for this. And so we say, maybe we'll take a little break from our dev work and go and have a call with the product manager, say, how can we help you break it down? How can we take some of the pressure off you? But in a similar vein, let me tell you about the strangest day of my career. I had been in hospital having a malignant tumor removed from my leg. And I went back to work. I was pretty sure, this was July 2020, I was pretty sure I had COVID. Everybody thought they had COVID. Went back to work, kind of had a few days at home to rest, and then stumbled into my office on my crutches and started getting these messages on Slack. Congratulations, well done, amazing. Got on a call with some of my colleagues and they said, we're the second most productive team out of all of these 40 teams. And I was so excited, I thought, well, this is amazing. And I thought, what does this mean? I thought maybe it had something to do with our DORA metrics because we were releasing frequently. We'd had very few post-production incidents. And when we did have incidents, we recovered really fast. So it was something to do with that. But I had this lingering doubt in the back of my mind because I thought about what we were actually delivering. And our product function had completely failed at that point. Our product manager was really good, but she was busy with a whole lot of COVID response stuff. And so we were making the stuff up. So initially we made up some of these cross-cutting things, like we would improve availability or we would improve performance. We'd work on that kind of thing. And then we started to make up business features because we just wanted to be as valuable as we could, despite the absolute absence of features coming into our team. So we made stuff up. And it was okay, but we knew that we understood the business quite well, but we didn't understand it well enough to be to do that kind of product management. But we did the best we could. Anyway, I went off to lunch. You'll notice lunch is a theme, beer is a theme. Went off to lunch, came back in the afternoon and hauled onto a call. And they said, your team has been fired. The work had been taken from our consultancy and given to another consultancy. The strangest day of my career. I don't really understand what happened there, and there's probably more going on than I imagine. But what I'd like, at least I think partially what was happening was, we weren't the only ones who could see that the features we were delivering weren't particularly valuable. So product managers love versions. We love things like alpha and beta and version 1 and version 2. And I call this version affinity, or virginity for short. As you can imagine, I spent the last 20 years trying to lose my virginity. So alpha, beta, what are these things? The way it works is somebody comes up front and says, we're going to do alpha first. That's our first release. It's this set of features. It's going to happen 3 months from now. That's alpha. And when we've done with alpha, we're going to do beta. And beta is this other set of features. And we're going to do that, start with alpha with beta as soon as we finish with alpha, and it'll be this set of features. And then when we're done with that, it's going to be version 1. And it starts to look like some old-fashioned thing like a Gantt chart or a waterfall kind of a plan. And so I was talking to one of my colleagues about this, somebody I really like and really respect, and he said to me, you need to have a minimum viable product. You can't just release features one by one. You can't just do this continuous thing from day one. And because I like him and respect him, I thought about it quite hard, and I thought, why are we disagreeing on this? What's the problem? So what I didn't say was, while we're building alpha, obviously they're perfectly good features that are hanging around, completed and ready for release, and we don't do them because they aren't alpha yet. And I thought maybe it's about saying we have to decide on these things up front, and maybe there's another way. So some kind of ritual like this, where you say, you build a feature, then you go to the product manager and you say, is this MVP? Is this the minimum viable product? Is this alpha? And she says, don't be silly, of course it's not. But so we say, okay, well, what's the next thing we need to build? And we talk about that, and we go and build that thing. And then we repeat the ritual. Are we at alpha yet? And she says, no, this next feature needs to be built. But eventually the answer is yes. This looks like MVP, let's go. Let's release it. And what happens then is that the thing that is finally MVP might be quite different from the thing that you imagined up front, because kind of requirements change and the understanding changes. We learn the environment better. But then we start to fly, because we can say, we've got the MVP now, we start to build the next features, and we don't hang around until we've got beta. Then we can get into some kind of cycle of continuous delivery. And that's how I hope to lose my virginity. So we've talked about these groups of people. So we talked about governance, we talked about hacking, we talked about changing, controlling change, we talked about dependencies. We've had a look at developers. We looked at how we're afraid of releasing code that hasn't been reviewed and some of the solutions we have to that. We've talked about quality assurance, saying, do we want to do end-to-end testing? Do we want to take shift left, as it's called? So do we want to make the quality assurance come in early in the process rather than leaving it to the end? And then we talked about product management and why product managers are justifiably afraid. So, continuous delivery. One thing you might have noticed throughout the course of this discussion is there's another sub-theme. There's a theme of incrementalism. So what we're saying, let's not try and hit the performance targets up front. Let's work slowly towards them. We can work incrementally towards them, and that applies to all the requirements we've discussed. And the same can apply to continuous delivery. So we don't have to say, well, we are at 6 weeks cycle time, and now we need to be at 6 hours cycle time. It just doesn't work that way. We have to look at these things one by one and work incrementally towards continuous delivery. There's a crazy story that where we were working with a customer who had an air-gapped network. And so it's in another country. So in order to make a release, we had to fly there, we had to burn a DVD, we had to go and spend a week installing. And because it was so expensive to make the release, we had to do this frequently. And so we decided to think about another way to do it. And we imagined, well, how do we do continuous delivery in this environment? And one kind of entertaining afternoon, two of us thought about this pipeline that delivers to this encrypted FTP site, and somebody on the other side downloads it automatically each night and puts it onto a flash drive and then goes and installs the system, and all that can happen semi-automatically, and we could do from something like one release a year to maybe one release a month. And we were getting quite excited, and then we heard about Stuxnet. Does anybody remember Stuxnet? So it was the virus that attacked the Iranian centrifuge and brought it down. And the way that the virus got across the air gap was on a flash drive. And so we thought, let's stop talking about that. But at least we'd come up with some ideas that helped us to move incrementally towards something more frequent than once a year. And so I think the way we can approach the problem of moving from these very long cycles to shorter cycles is incrementally a little bit at a time. And maybe if we do that, we can get to some form of continuous delivery if we still want to. Thank you.